power, it's a unit of power. 40 watts, it's telling me, as I switch on, the electricity flows, energy is being transformed there. How much energy? Well, if it's 40 watts, it's 40 joules per second. So then there's meaning behind that term watt. It's so many joules per second. It's how much energy I'm getting here per second. So the little coulombs come up here with 220 joules in their bag. They're going to dump it here at the rate of 40 joules per second. And then they'll return with no joules left in their bag. So that gives them the meaning of watt. There's a current flowing through here. What do we measure current in? It's amps. What is an amp? Say 2 amps are flowing through here. 2 amps means 2 coulombs per second. It gives us a measure at the rate at which electricity is flowing, at what rate, the speed with which these coulombs are moving through here. Let's have a look at a 60 watt globe. It's brighter. Why? Well, at 60 watts, I'm getting 60 joules per second coming off that one. Why is this one brighter than that one? They're both connected to 220 volts. Well, we'll talk about it, and ultimately they'll see, well, there's more energy per second coming out of here than there, so therefore there must be many more coulombs going through here. They're delivering it faster than here. So this has got less resistance to the flow of charges than that. So a 60 watt globe has got less resistance than a 40 watt globe. So we start talking about the concept of resistance to students. The whole concept of power and resistance, it's cemented by bringing in another appliance. This is a kettle. If I read the label underneath, it says 2000 watts. In other words, 2 kilowatts. What does that mean? It means that if I'm boiling water in here, I need energy, and therefore it's going to, by connecting to the power supply, I will get 2000 joules per second. I'm going to boil my water quite quickly. What about the resistance of this? How does the resistance of this kettle compare to the resistance of the bulb? I talk about that with the students, and ultimately they'll see, well, if I want to get more energy there quickly, I need lots of coulombs, therefore it must have very little resistance. And out of it they get, the higher the power, the lower the resistance. I haven't resorted to any formulas. It all is basically making sense. They're understanding from what they're observing what's going on. Once I'm through that, I'll then get into some fun with them using the circuit board. Take 40 watt globe, 60 watt globe, and let's connect them in series. I'd ask them to predict, what do you think you're going to see there? Will one be brighter than the other? Will they both be the same? Because electricity is going through both of them. What do you think? Very important to get people to predict